Hi everyone, thank you for a nice introduction. My name is David Stevens and I'm from a media company in Sweden called TV4. And I'm here to talk to you guys about the work that we do at TV4 and the Finnish equivalent MTV3 to enable developer autonomy through infrastructure as code and policy as code in order to operate true DevOps teams. This presentation is going to be a bit of a whirlwind tour of the work we do, so strap on in and get comfortable. I'm going to start by talking briefly about who TV4 and MTV are, because while these are household names in the Nordic market, we don't operate at all outside the Nordics, so most of you probably haven't heard of us. Then I'm going to talk about the work that I've done to help developers write infrastructure as code using CDK for Terraform, and finally talk about the work I've done to help developers write good infrastructure as code using OPA, or Open Policy Agent, because there's a key distinction between these two things. So first, starting off, TV4 and MTV. These are the two largest commercial TV channels in Sweden and Finland. They have a massive outreach to the local markets, and they are sibling companies that are currently both owned by Telia company, which is why we collaborate very closely using a shared infrastructure platform and large amounts of shared code in the code base. The two TV channels, in addition to broadcasting TV, also have streaming services with millions of users. So we are quite heavily embracing the digital transformation, as they call it in a fancy way. But basically, we've transitioned largely to digital streaming from linear broadcasting. And all of this is deployed on AWS with a bunch of different microservices. Our usage of OpenTofu is completely standardized and completely centralized. We use it exclusively to manage the cloud resources that we have in AWS. In total, we have more than around 300 different OpenTofu projects. This is different microservices that we operate internally. And this adds up to about 1,400 workspaces when you cover both brands and different development environments, staging environments, things like that. In total, there's about 18 different teams that operate their own infrastructure, and these are teams across every discipline. So at TV4, the front-end team with Next.js developers are in charge of operating their infrastructure the same way that a data science team might be, or a back-end development team. All of them own their own infrastructure because ultimately they are the team that has the best understanding of what they need. But of course, this introduces a lot of challenges because there's quite a lot of knowledge gap for some of these people. So that's something we need to work on. In total, we have around 80 different active OpenTofu users, and very many of these are consultants. The result of this is that onboarding and making that process as fast and as efficient as possible is really critical to the way that we operate, because that onboarding process happens all the time and is quite expensive. And all of this is supported by my team, a cloud infrastructure team of 5 people, of which 2 focus on platform engineering. So getting this scaling to work where 2 people are able to support 80 people also requires a lot of special attention. And in particular, it requires us to help the developers. Because the big problem that we see in a lot of organizations is that it's very easy to try to force developers to embrace the way that us infrastructure people are used to working. The approach that we've taken at TV4 and MTV is flipping this on its head. We try to adapt the way that you work with infrastructure to be a better match with the way that developers are used to working. And you might be wondering why we need to do something like this, because obviously we all like OpenTofu. This is a room full of people who would travel across the world to go to an OpenTofu convention. But sometimes it's good to remember that some people might not be quite as comfortable with infrastructure as code, especially when you force these teams to operate their own infrastructure. And the key in this, the key thing that is the most difficult thing about OpenTofu for beginners is that infrastructure itself is incredibly difficult. This is unavoidable. If you've looked at any public cloud infrastructure provider, there's a million different configuration options that you can set, and there's a million different services that you can combine in exponentially more ways. So this part is unavoidable. There's no way for us to reduce the actual complexity of the cloud. So what we're instead going to be focusing on is reducing the complexity of everything else. And one such thing is HCL. itself. This is the configuration language that you use to declaratively write OpenTofu. And while it's quite nice, once you get used to it, it can be unintuitive for people who are used to imperative programming languages and quite a big change of mindset, especially when you consider the meta arguments that come in, like count, dynamic, for each, things like this. As soon as OpenTofu tries to be more imperative in a way, it becomes quite confusing. This is something that Mike covered in his talk earlier this morning. So if you attended that, he had half of examples that I was planning on bringing up. And one such example is also the way that conditionals work in OpenTofu. Because in HCL, consider that you're writing a module or something like that, and you have certain resources that you may or may not want to enable depending on some input value. A conventional way to do this would be to have a count meta argument that checks some input variable, and if it's true, you set it to 1, otherwise you set it to 0. This works, but it's really difficult to keep track of once you start writing a very large module. And I'm sure that anyone who has tried looking at something like the AWS modules or something like that, the actual source code to it, you would get overwhelmed with trying to keep track of what is enabled in what circumstance. And this doesn't just affect people who write modules. It doesn't just affect us, the platform engineers. It also affects the developers who might want different configuration for a development environment as opposed to a production environment. Another big pain point that we bump into quite often is stringly typed providers. Because while Terraform and OpenTofu itself is strongly typed, and the provider schema can tell you that this field is supposed to be a number, this field is supposed to be a string, sometimes the provider will just say this field is supposed to be a string that contains a big JSON blob of data. And I'm sure we all have our favorite or least favorite examples of this. Mine in particular, we heavily use AWS ECS as our container runtime. And they have this one resource called ECS task definitions, in which there's a field called container definitions, which for Kubernetes folks is essentially the pod specification. And it has on the order of maybe 50 different inner fields that all have different type information that is completely not typed in the provider. It's up to you to make sure that you keep track of everything. And we bump into issues with this all the time. There are also a lot of providers where validation happens at apply time instead of plan time. And this really slows down the developer feedback loop because they would open a pull request, try to get their code out, go through this whole review process, and then apply their code, only to find that their load balancer in AWS has a name that is longer than 32 characters, and it crashes, and we have to start over and do everything again. Finally, sharing constants and state can be a bit difficult in OpenTofu. Constants could be things like trusted IP networks, like your Office network or things like that. As far as I can tell, the best way to do this is to have some kind of shared module that only defines a bunch of outputs, and then you read those outputs. But this becomes quite tricky to handle. I'm seeing some nodding in the audience, so I think some people might have bumped into things like this before. But most of all, OpenTofu and HCL is just yet another thing to learn. And this adds up. And every single thing that you need to learn during an onboarding process means that the onboarding is longer. So what we chose to do instead is to try to meet the developers where they are. And we do this using the Cloud Development Kit for Terraform and OpenTofu. It's named that because it's a HashiCorp project. And this is basically a way that you can write your OpenTofu in TypeScript, which then gets compiled to HCL or JSON. Yeah, good, that's somewhat visible. Developers don't need to learn new syntax when you do this. They only have to focus on semantics, like focus on the actual concepts of infrastructure as code and not need to worry about how you would actually define things in HCL. Examples of this would be for loops. For loops work exactly like you expect. You can do for loops over providers, even if you don't have OpenTofu 1.9, using this, which then would get compiled down to just separate statements for each provider. Think of it like the most complex templating language you can imagine, basically. So for loops work like you expect, except when they don't. I don't really have time to get into that. If statements work the way you expect, bindings get automatically generated for every single Terraform provider and every single Terraform module, even if you have custom in-house modules or providers. You just run a single command and it will introspect the schema of your OpenTofu provider and generate bindings for this so that you can use everything. It also comes with a CLI that enables things like stack dependency ordering, where if you have a reference from one workspace to a different workspace, the CLI will actually be able to identify this and make sure that the workspaces are applied in the correct order or destroyed in the correct order. That destroy thing has been a pretty large pain point for us, because sometimes the easiest way to fix destroying things in the wrong order is to reapply the thing you just destroyed, which always feels a bit bad. And this is also supported in Python, Go, C# or Java if you prefer those languages over TypeScript. But for us, TypeScript is kind of the least common denominator that all developers understand in our organization. And it also provides some nice features with typing that you can do. So you might be asking yourself, isn't that just OpenTofu but with extra steps? Because ultimately, all of the code that you write in TypeScript is going to get compiled to OpenTofu, and the thing that's actually going to be executed against your cloud environments is OpenTofu. You can't actually do anything in CDKTF that you can't do in OpenTofu. But there are a host of benefits that you get instead by using this as a really powerful templating language. The first of these is that all of the meta arguments that can be hard to understand are replaced with familiar constructs for most developers. You can also create arbitrarily strong type wrappers over stringly typed providers. This is something that we do quite extensively internally to patch over things that we wish were different in a provider. You can also run arbitrary JavaScript functions during compilation. This might sound scary, but it's quite powerful actually, because it allows you to do things like configure remote backends or providers or things like that in a more dynamic way based on, for instance, the file path that your configuration is in. And perhaps most significantly, it enables you to write your modules as JavaScript packages instead of being regular HCL modules. Once you do this, you can start working with object-oriented modules instead of just having composition. So you could, for instance, have a CloudFront CDN with a VPC origin, which inherits from the CloudFront CDN with a generic origin, allowing you to just restructure the way that you do your modules, and it becomes a lot easier to keep track of things. It's completely trivial to share constants, because you can just export anything in JavaScript. And you can even do custom functions in modules this way. Because in your JavaScript package, you could export whatever you want, including functions. And this is actually something that's close as not planned in OpenTofu, because it breaks compatibility with HCL quite extensively. So that's kind of an interesting thing that you could be doing. And another interesting thing you can do is that you can actually abstract away the Terraform block itself and provider configuration. So one thing we do very extensively, developers never have to think about which backend we're using or the name of our workspace or anything of that sort. All of that is automatically set by our CDKTF library, which they use. So let's have a quick look at how such a library might look. What you see here is just a super simple class, which extends the base class Terraform stack, which is basically a Terraform workspace. Within the circled pieces that you have here, I have a remote backend configuration that uses some environment variables to determine the host name that you're going against. It names the workspace based on the path of the current file. All of this is, of course, made up. We don't do exactly this, but we do something quite similar. And it leads to developers not having to think about these things and it just happening. We also have a for loop in the second red circle that initiates different AWS providers in a somewhat dynamic way. So this class, in its constructor, it takes a list of AWS accounts that you would like to deploy to, and then it instantiates AWS providers for each of the accounts that you have provided, assuming different roles and setting different default tags based on the inputs that you have passed to the class. This is quite a powerful abstraction, and it allows you to standardize things a lot easier across your organization. For instance, we were able to introduce global cost allocation tags across every single workspace in our organization by just asking them to update version of our helper library. And then it would automatically set tags based on some different metadata that we already have. You can also export whatever you want. So in this example, we're exporting an enum with a team tag, which is then assigned to the default tags in the provider. And we're exporting some different account IDs or something like that. This could be CIDR blocks, like I was mentioning earlier, or whatever you want. You can run arbitrary JavaScript. So like I was mentioning earlier, here we're actually generating the workspace name based on a file path. This JavaScript could also be like a web request. It could be literally whatever you like. And all of this would, of course, be done during compile time. So this is not something that's being executed when you're actually running your apply. So you will be able to see all of this in your Git version control history. And if we look at the usage of this library, in this case, we have a simple stack that instantiates the library that we just created for the development and the production account. And for each account that we have chosen, it creates an EC2 instance for this. So this is a for loop over providers for each loop. So similarly to what you nowadays are able to do in OpenTofu 1.9. You're also able to provide strong type wrappers. So I was talking about ECS task definition, container definitions earlier. In this example, I've created a subclass of a task definition that works the same way as a regular task definition, except that for the container definitions field, it accepts a typed custom type instead of accepting a string. And then within the subclass, we do the JSON encoding instead. This allows you to actually get error messages in your editor if you have a typo. In this particular case, it's extra scary because that particular typo would not only not be caught during apply time, it wouldn't be recognized at all by AWS, and AWS would just default to false in this case. So even if your code seemingly sets your root file systems to read-only, they wouldn't actually be read-only, and you would have no way to know unless you go into AWS and look at the actual configuration that it results in. That's quite scary, but nowadays, by having a typed wrapper on top of it, the developer would immediately see this error. So let's look at some pros and cons from our experience using CDK for Terraform. The first is that for the people in this room who work as platform engineers, object-oriented programming kind of helps with writing modules. It's a lot easier to maintain. I gave some examples of inheritance earlier. You can also add methods to add further configuration later. So this is really helpful for breaking cycles between different modules. For instance, you might have some database module and then some app module, and then you have to add a reference between the security groups to allow ingress between them. And it's a bit unintuitive how you would be able to order this correctly, potentially needing to break it out into a third module that creates the link between the two. Using object orientation, you could just add a method, which you can call later, called .addIngress or something along that lines. It also allows you to add more degrees of abstraction. So there's no need to configure backends if you don't want the developers to configure backends. You can set defaults. This makes it easier for you to eventually migrate between backends if you're looking to do that. And it's truly like being able to add custom static typing has been a superpower for us. This is something that has been a huge benefit to myself as a somewhat experienced OpenTofu user as well. And it's kind of one of the things that I miss the most once I start writing plain HCL again. But it's not just me who likes this. The actual developers at TV4 and MTV have also been very fond of this. And onboarding has become a lot faster. In fact, we don't really even have to get involved in the onboarding of developers. They kind of just onboard each other to the way that they work with this. But it isn't all great. The first and most clear drawback is that it's kind of unclear what the future support for CDKTF is going to be like. This is a HashiCorp project, but there have been no major updates since January 2024. As far as our organization is concerned, it's more or less feature complete, but it's still a bit concerning that it isn't being updated. And the CLI is kind of hard-coded to Terraform when it comes to defaults, so you have to do some workarounds to get it to work properly with OpenTofu. Disk usage is another major pain point. The AWS provider bindings, because it's a massive provider, the TypeScript bindings add up to about 352 megabytes once I last checked. And that's going to be 350 megabytes for each project installation. So if you have this across hundreds of different microservices, that all becomes multiplied very quick unless you do some clever things with NPM caching. It also has a tendency to get quite ugly when the abstraction eventually breaks. There are ways to add overrides in plain HCL to your CDKTF, but every time you do it, it feels like an angel is dying or something along that lines. But overall, I would just like to finish the CDKTF part with some advice. The first is to make sure to dog food this. One thing that's been a huge help for us is that the biggest user of our CDKTF library is my team, the platform engineering team, who are the ones developing it. This helps us identify room for improvements, and it helps us support the developers because we are more familiar with how things are structured. It's also really helpful to build different levels of abstractions. So the AWS CDK, they have levels for raw resources. They have a level for instance, image repository with some associated policies, and then something on a very abstract level. And this allows developers to opt into more detail if they want, or stay on a high level. I'm just going to quickly zoom through this because I do want some time to talk about OPA as well. And finally, make sure to hang out with the developers. This is really, really important because often this is the only way that you're going to hear about the small minor gripes that they wouldn't report in the ticket otherwise. So moving on, how do we make sure that the code that the developers write is actually good and help close that feedback loop? The biggest problem here is, like I said earlier, that infrastructure itself is overwhelming. There are so many configuration options. And while your high-level abstractions can set sane defaults, eventually developers have to make their own choices and go beyond the safe path that you have set up. And this becomes further complicated by defaults not always being sane in providers. For instance, in AWS, their managed Redis service still defaults to Redis, even though there's no real reason you should ever be using Redis instead of Valkey, because Valkey is backward compatible, cheaper, and faster. It's kind of just a win-win. It's also very easy to misuse resources. One common thing that's happened at TV4 is only using the primary node endpoint in a read-replicated SQL cluster or something like that. This way you don't actually have a cluster, you just end up with a single instance taking all of the load. And of course, security. So at TV4, historically, we have tried to hide as much misconfiguration as possible in abstractions and setting defaults. And we have set up different detective controls that reactively scan for misconfigurations, which we then talk to the developers about retroactively. But none of this is scalable, and it's a bad developer experience because the iteration cycles are so long. Like, we might discover these things days or a week after they thought they were done with their ticket. So instead of being reactive, we've moved to being proactive. And what we do is that we want to detect a misconfiguration in your Terraform or OpenTofu plans before you've actually deployed the infrastructure. This would offload the cloud infrastructure team by automating all of this and speeds up the feedback loops for developers because they can see it immediately instead of having to wait for us to come later. And the thing we found is that initially it's enough to just warn on misconfigurations because developers tend not to like warnings in their pipelines. So they'll fix things on their own. And we've been doing this through Open Policy Agent, or OPA. In Open Policy Agent, you write declarative rules in a language called Rego. And we have some security best practice rules, and we have some recurring misconfigurations at TV4. And these are incorporated into your OpenTofu pipeline, run on plans. And there's built-in support for this in most OpenTofu backends. So it should work wherever you are running your OpenTofu. Here's an example rule. So this rule is that if you run ECS Fargate, you should be using the latest platform version so that you automatically get security patches. This top example is an invalid configuration because it pins the platform version, and the bottom one is a valid one because it uses the latest magic keyword there. So the way we write this in OPA is that for some service in the resources that our plan is touching, where the service is of type ECS service, we check that the launch type is Fargate and the platform version isn't latest. If all of this is true, then a violation has occurred, and we have some kind of output that we feed the developer. So the output is this part that you have here. And resources in this case is a little magical helper function that we have defined. It's incredibly simple. All of this is just based on scanning the JSON output of Tofu, which has, like they were mentioning, it has a full compatibility promise with Terraform, so everything will work across both OpenTofu and Terraform. And basically all it does is that it checks for all the different resources that are being changed, if the resource has the intended type, and if the action we're doing is a create or an update. So this way we don't alert on things that aren't being touched at the moment. It's really not more complicated than that, and you can scale this to as many rules as you like. And developers have been incredibly fond of this. We've had developers come up to us and ask questions for correcting security misconfigurations that we never dreamed they would care about. So that's been really lovely. It's also been a way that we can write unit tests essentially for recurring misconfigurations internally. So this way we can avoid having the same errors be introduced in new projects. It's also very easy to write unit tests for the policies themselves. But there's kind of a lack of a package manager in OpenPolicy Agent, and the import and namespacing structure can get quite confusing if you're not used to it. And there's fewer pre-built policy packs compared to alternatives like Chekhov. But we are trying to help with this by open sourcing the policy packs that we are building at the moment for AWS. So what's next for TV4? We're going to go all in on OPA. We want to introduce more policies, potentially introduce a pre-commit hook to check Terraform before you've even committed it, and run policies against existing state, not just things that are being changed. We're also interested in investigating how we could improve OpenTofu support in the CDKTF CLI. And most critically, we're going to keep listening to developer feedback and keep iterating. So the take-home message from all of this that I want to give to all of you is that as a platform engineer, making things easier for the developers actually makes things easier for you as well. Like, the amount of support that we've had to offer developers, the amount of time and effort that has taken has gone down drastically over time as our libraries have gotten better and better. So it really is something that is beneficial not only to them, but also to you. Thank you so much for listening, and there's going to be a text version of this on my blog as well if you guys want a 3-paragraph long rant about ECS task definition. Thank you.
Thank you, David. You mentioned CDK for Terraform not being updated in, what, 14 months or something like that? Besides that, like, what would be on your wish list? What would you, how can it become better for OpenTofu, et cetera?
I think the biggest pain point in CDKTF is specifically these leaky abstractions. So there's one example that I didn't bring up, which is iterating over dynamic attributes. And one thing that comes up often is like a DNS-validated TLS certificate, where if you want to iterate over the DNS validation records that are dynamically generated, you have to do all of this weird stuff with this Terraform iterator magic. And this really doesn't feel like you're writing TypeScript anymore. At this point, I would rather write the corresponding just plain HCL, because it's very clear that this is what you're actually doing. So if there were some way to like close that loop, that would be huge for us. Great. I think I'm over time. So thank you again for listening.